Hi, welcome back to the another session. I am Dr. Shekhar, working as an associate professor in Mlritm, Hyderabad, Dundigal. Last time we have discussed about the two topics, that is one is water and its treatment and the second one is battery and corrosion. These two topics we are covered in our last sessions. Now I want to discuss about the another one of the module or unit which we are included in JNTU Hyderabad syllabus, that is nothing but the polymer chemistry or polymeric material. Once again, welcome to the session. In this topic, today we will discuss about these topics we are covering in the today sessions. That is nothing but the what is definition of the polymer and the classifications of polymer with example we are seeing, and mainly we are discussing about the what is a polymerization and how many type of the polymerizations we are discussing today in this session. Along with this polymerization, we will see with examples. And today, now I am going to start the main topic, that is the polymer. Polymer is nothing but it is a Greek word. Polymer is a nothing but a Greek word. The poly means many or plenty or number of. Poly means plenty or many or number of. Mer means units. Means polymer is combination of many units or multiple units. So that is a simple definition for a polymer. And when we are talking about the polymer are generally made of with macromolecules. Polymers are generally made of the macromolecules. The macromolecules we called as a monomer. The macromolecules we called as a monomer. The combination of monomer, the monomer are reacting together or they are linking together and we are getting the polymer. And the polymers are made up with the macromolecules. Already we are said sometimes the polymer is molecular weight is equal to the number of monomers participated. That is also we are observing in this case. And already we are saying the polymers are made of with monomers, and the what is the monomers? The monomers is micromolecules. The monomers is micromolecules. These micromolecules are combined with each other and we are getting a polymer. For example, the ethylene, the vinyl chloride or the propene, these are some of the monomers we are seeing. And coming to the classifications of polymer, different type of so many number of polymer classifications we have, on that we first of all the based on the source we are discussing about the classification, and based on the structure also we are discussing about the classification, and the another one is based on the reaction mode. The based on the reaction mode also we are classification of the polymer. The another one is force, molecular forces. Based on the molecular forces also we are talking about the classifications. And that the first one, the based on the source. In this, the based on the source, polymers are classified into two types. One is natural polymer, the second one is synthetic polymer. In this natural polymer, we are not doing anything. The nature itself producing or given this type of polymers. Because we said the cotton, for example, the cotton, the silk and the cellulose and the natural rubber, the hevia braziliensis, the latex, the natural rubber, these are nature given to us. So because of that reason, we call these are natural polymers. And second one, synthetic polymer. The synthetic polymers also called as a man-made polymers. Means the human being to survive their life, they are preparing this kind of polymers. So because of that reason, the synthetic polymers also called as a man-made polymers. So here to understand the human polymers or man-made polymers. For example, the nylon 6 and nylon 6,6, the polyethylene and polypropylene. These are some of the synthetic polymers we are seeing. And coming to the another type of the classification based on the structure, based on the structure of the polymer backbone. Based on the structure of the polymer backbone, this classification we have three types. One is linear polymers, the second one is branched polymers, the third one is cross-linked polymers. First we will see about what is mean by the linear polymer. The structure of the polymer backbone chain containing long and straight chain. If for example this is our polymer, if this polymer is containing long and straight chain, so if this kind of polymers we called as a linear, if the structure is look like a linear structure, so because of that reason this kind of polymers we called as a linear polymers. For example, if you see the PVC, polyvinyl chloride, is best example for the linear polymers, and the second one is branched chain polymers. The second one is branched chain polymers. In this branched chain polymers, this linear polymer contain some branches. These linear polymers contain some branches, means addition of the more monomers. We called this type of the polymer we called as a branched polymer. It is look like a tree containing branches. It is look like a tree containing branches. So because of that reason this kind of polymers we called as a branched chain polymers. And the third one is cross-linked polymers. And in this cross-linked polymers they are composed by a trifunctional monomers. If you see this kind of monomers, simply we called as a cross-linked polymers. See, these are the cross linkages made with the monomers. This kind of the polymers we called as a cross-linked polymer. These three types of polymers we are classified based on their structure. The first one is look like a straight chain. The second one, it contains some branches. The third one, it is look like a cross. These three types of we are seen. It is another type of the classification. And the next type of the classification based on the polymerization. Based on the polymerization of polymers, this classification is two type. One is additional polymerization or polymerization. Second one is condensation polymerization. These are two type of the polymerization we have. In addition polymerization, in condensation polymerization. What is the main difference between these two polymerizations? In addition polymerization, we are not getting any byproducts. In addition polymerization, we are not getting any byproducts. In condensation polymerization, we are eliminating some byproducts. We are getting some byproducts. It is a main difference between the addition polymerization and condensation polymerization. These addition and condensation polymerization we will see in detailed explanation. Before going to that, here another one type of the classifications we have. This is based on the monomers. Based on the monomers. Already you know the linkage of monomers, we are getting a polymer. The linkage of monomers together, we are getting the polymers. These monomers again two types. These monomers again two type. One is homomonomer, second one is heterohomomer or copolymer. First one is homomonomer and second one is heteromonomer or copolymonomer. In the homomer, to easily understanding this diagram will helps to you. What is in homo? In this monomer, which monomer units are present? The monomers all are in single type. One type of the monomers are present. The type of the monomer or polymer we called as a homopolymer. We called homopolymer means the present of monomers all are belongs to the one group or one type. And second one is heteropolymer or copolymer. In the hetero or co means different, more than two types or more than one type, two or three different type of the monomers. Due to different type of the monomers we are getting the copolymer. To understand that, this diagram will helps you. So you can see in this, it is a homopolymer. We have all are same monomers are present in carbon backbone chain of the polymer. But if you see in copolymer, we have the, it is for example it is a type. If you see, it is a B type, means more than one or two we have the different type of the monomers. By that we are getting the copolymer. It is a two type of the polymers we have be based on their monomer structure. Based on monomer structure, these two type of the monomers classification we are seen. And now we will discuss about the one of the more important topic in the polymers, that is nothing but the polymerization, means formation of polymer process. The formation of polymer process we called polymerization. In the polymerization, again already we are said that is two type. One is addition polymerization, the second one is condensation polymerization. In the addition polymerization and condensation polymerization, we will see in detailed explanation. In the addition polymerization, for example, to explain the addition polymerization, the free radical addition polymerization is best example for us. Okay, to discuss the free radical addition polymerization, first what we will see what is the definition or characters of the addition polymerization. We will see it is a reaction that yield a polymer which is an exact multiple of the original monomeric molecule. By the addition polymerization, if we are preparing a type of the polymer, the polymer molecular weight is exactly to the monomer. This kind of the polymer we are getting with the help of the addition polymerization. In the addition polymerization, the original monomeric molecules usually contain one or more double bonds. In this, we contain one or more double bonds we are contain. In the addition polymerization, there is no elimination of any molecules. Means already I said there is no elimination of byproducts. We are not getting any byproducts in the addition polymerization. To understand the addition polymerization, preparation of polyethylene, it is the best example. It is a simple structure to understand the addition polymerization. See now what we have here. We have the ethylene. We have the ethylene monomer. We have two carbons containing a double bond. We have the n number of ethylene monomers. We have the n number of ethylene monomers. They are undergoing in polymerization reaction in the presence of catalyst and heat. In the presence of catalyst and heat, we are getting the polyethylene. It is a ethylene monomer. It is a polyethylene. It is a polymer. Polyethylene polymer we are getting. To understand this process, the formation of addition polymerization, it will take the 3 steps. These are the 3 steps are involving in the addition polymerization. The first step is initiation. The second one is propagation. The third one is termination. These 3 steps are involving in the addition polymerization or chain polymerization or free radical addition polymerization. In what is mean by the initiation? In the initiation, we need the initiators. To initiate the reaction, we need the initiator. Here we are taking R dot. This R dot means nothing but it is a radical. It is a free radical. To mention that free radical, we are using R with star. Means that is a free radical. You know the free radicals are active species. They are ready to involve to participate in the reaction. This free radical is reacting with one of the monomer, that is our ethylene monomer, and this free radical when reacting with ethylene, the electron is shifting from a free radical to the monomer. Now we are getting the ethylene free radical we get. This ethylene free radical, the same ethylene what we are took here, that is same ethylene free radical, it is again reacting with another same type of the monomer. And now you can see when compared to the step 1, the chain length was increased. The chain length is increased. So because of that reason, we called it is a propagation. Propagation means increase of the carbon chain. We called as a propagation. In this propagation, the carbon chain length was increased. And in the termination, what we are doing, what we are getting in second step in propagation, the same type of the free radical monomers we are taking, and the two type of the same, they are reacting with each other. They are reacting with each other and they are forming a bond between these two monomers. Now there is no free radical is present, so the chain here is terminated, means the chain is dead. This we called as a termination. So these three steps are involving when we are discussing about the addition polymerization or chain polymerization or free radical polymerization. First is initiator is required to initiate the reaction. After that, the initiator, the free radical, is reacting with one of the monomer, and the monomer again reacting with another monomer, that is nothing but our second type we called as a propagation. And that propagation, again the third step, we want to stop the polymerization process. So the polymer we called as a, by the using of termination, we called as a polymer is dead. These are the three steps are involving. In the three steps, if you see, there is no elimination of any byproducts. We are not observed any elimination of the byproducts in these three steps. Now we will go for the second type, that is nothing but the condensation polymerization or stepwise polymerization. Condensation polymerization or stepwise polymerization. The addition polymerization, what we called the chain polymerization. Addition polymerization also called as a chain polymerization or free radical addition polymerization. Like that here, the condensation polymerization also called as a stepwise polymerization. In the stepwise polymerization, what will happen, we will see. It is a reaction between simple polar groups containing monomers with the formation of polymer and elimination of small molecules. This word is important for us. What is elimination of small molecules? In addition polymerization, we are not eliminating any byproducts, but here in condensation polymerization, we are eliminating the simple and small byproducts like water and HCl, like that. To understand the step polymerization or condensation polymerization, the thiocol and the nylon 6,6 and bakelite, the terylene, these are some of the examples, best examples for the condensation polymerization. We will see here the nylon 6,6. Preparation of the nylon 6,6, the best example for explanation of the condensation polymerization. In the nylon 6,6, what will happen? Two different monomers. One is hexamethylene diamine. One is hexamethylene diamine, it is one monomer, and second one is adipic acid. These two monomers are undergoing in polymerization. These two reactions are undergoing in polymerization, and we are getting the nylon 6,6. This is a simple polyamide, the nylon 6,6. Now here, why we are using the two sixes, the nylon 6,6, why you are using here? Because if you observe the two monomers, the monomer 1 and monomer 2, if you see, we have the 6 number of carbons we have. In hexamethylene diamine, we have the 6 number of carbons we have, as well as in adipic acid also we have here 4, it is a 5, it is 6. The here also we are using the 6 number carbon of the monomer, the 6, and here the 6 are here. So because the to represent that, we are saying it is a nylon 6,6. In this process, here we are getting the water as a byproduct. When, how will it will happen? Now the simple reaction to understand that one, these are the one of the hydrogen, and it will like that. So remaining the NH2, the NH and CH2 and NH2 we have here, but we have only NH, one of the hydrogen is when, and for COOH we have here C double bond O. So hydrogen from amine and OH from the adipic acid, we are removing, water we are removing at that one of the byproducts, or simply we can write plus H2. Like that, in condensation polymerization we are discussed, and these are some of the reference books to help you to more understand this topic. Okay, today in this session, up to the general classification of the polymers we are discussed. Next we will discuss about the remaining syllabus what we have in this plastics. Next, the plastics and rubbers and elastomers, these topics we will discuss in our next session. Thank you.